Hey guys, welcome back to Business Statistics. This is going to be the video for 4.4, the Poisson probability distribution. Okay, this is our third discrete distribution that we've learned, but our second named discrete distribution. We've learned like kind of the standard discrete distribution. We've learned the binomial distribution, and now we're learning the Poisson distribution. Okay, this one, the formula looks a little ugly, but it's nice that it's small. But yeah, we're going to learn this in a similar way that we learned the binomial in the last video, but this is, I think, a lot simpler of a computation, so we'll be able to just do the problem, like on screen, but I will also show you the Excel way to do it and also the table way to do it, so that'll be helpful. Okay. Poisson distribution. A discrete probability distribution that provides probabilities for the number of occurrences over some event or a given period, interval, distance, or space. Okay? So like the easiest explanation of this would be like if I asked you the question, and I think maybe I mentioned this in a prior video, but if I asked you the question, what is the average number of cars that goes through a drive-through restaurant during a rush hour? So our unit of time would be like an hour, okay? And then we would be wanting to know the number of occurrences that typically go through during that hour. So like, if we're talking about like Taco Bell or something, and we say, well, from 5 to 6, like the average number of cars that go through a Taco Bell are 25. So then our mean, our average is 25. Okay. But then the Poisson distribution or the Poisson probability formula. This probability formula says that given this sort of average that we have, given this mu that we have, what is the likelihood that X number of cars go through during this amount of time? So during this hour. So then our X would be 10, our X would be 15, or whatever we choose X to be. But then we would be evaluating based upon that what our likelihood is of that certain number. Sorry about that. I just needed to take a phone call. And now we're back. Okay, so it says the probability that the specified events occurs X times over some defined interval is given by the following formula. This is just P of X. So the probability of X, and an X member is a specific number, is equal to mu to the X, e to the negative mu over X factorial. Okay, and now remember in this course we don't get into the theory behind it. It's not important, I don't think, for business students. Business students, it's more about learning a tool and being able to use it, okay? So this is our formula. This is going to give us the probability of a specific event, right? So in that given Taco Bell thing that I just mentioned, we're talking about the probability of 10 people going through the drive-through and knowing that, like, well, the average is 25. Okay, so that's what we're looking at. Okay, so let's go ahead and get into an example, and we're going to solve this, like I said, multiple different ways, multiple different options that you have on the table. So that's that. All right, so an example. Oh, and let me mention, mean is equal to mu in this scenario, which is simple. Variance is equal to mu, which is simple. And standard deviation is just, as always, the square root of the variance. So that's good. Cool. All right, example. An accounting professor has observed that the number of typographical errors in a new textbook is Poisson distributed with a mean of 1.5 per 100 pages. The instructor randomly selects 100 pages of a copy of the book. What is the probability that there are 2 typographical errors? Okay, so here's one thing that I do want to mention that I think is very, very, very important for you guys to note. On a test, okay, for Poisson specifically, it will be noted when you're using Poisson, okay? So this isn't going to be something where you have to determine, oh, what kind of experiment is this? Is this binomial? Is this just a standard discrete? Is this continuous? Is this uniform? Whatever, right? It will be explicit. It will be told to you that it's a Poisson distribution, okay? So that's kind of nice. So there's no guesswork there. Like, we will specifically define something as being Poisson if we're looking at Poisson. Cool? Cool. Perfect. So it will be in this sort of format where it tells you it's Poisson and it gives you an idea of the mu, okay? The instructor randomly selects 100 pages of the book. What is the probability that there are 2 typographical errors? Okay, so perfect. So let's, as always, when we tackle one of these problems, let's write down what we know. Okay, so the mean of 1.5 per 100 pages. So mu is equal to 1.5. This 100 pages isn't really important, okay, unless we veer from 100 pages as being kind of the standard, okay, because so 100 is not our x value, 100 is not our e value or anything like that. Note, maybe we didn't mention this, but e is Euler's constant, so it's just a mathematical constant. So you can find it in your calculator. It's like 2.78 something or other. But yeah, so we use Euler's mathematical constant in this, okay? So the important thing is we need to know, okay, what is our mu and what is our x that it's asking for? Well, our x is 2. And our x is always going to be like a whole number, right? So our average can be a decimal, but our x has to be a whole number because this is discrete. So let's solve this problem. We're just going to go ahead and solve it. So the probability of x, is actually the probability of x equals 2, okay? And that is equal to mu to the x, right? So 1.5, which is mu, to the x, 2, times e to the negative mu, okay? And then x factorial, 2 factorial. Okay. So I'm not going to go ahead and calculate that out hand by hand, but you can do 1.5 squared in your calculator, and I think it'll get you 2.25. E to the negative 1.5 is 0.22313, something like that. And 2 factorial is just 2. And then that is all going to shake out to be roughly 0.2510. Okay? So that's that. That's that. So now we calculated the probability that exactly 2 typos were in this textbook in this randomly selected 100 pages. So the probability that exactly 2 typos are in that is roughly 25%, is 0.2510. Okay? So let's go look at another way to do this. Okay? Let's go over to Excel. And let's type in our formula here. Equals Poisson.dist. So sometimes when you don't know the formula on Excel, you can just start typing in something that you think might be the formula, and then it'll just complete it for you. It's actually really, really nice. Excel does a really good job about being super user-friendly. Okay, so we're looking at Poisson.dist, so Poisson distribution, and then x is going to be our number of successes or our number of occurrences there. So this is going to be our x value of 2. And our mu, or our mean, is the next thing. And that's 1.5, we said. And do we want to know cumulative? No. We want to know exactly the x equals value. Okay? So we say 0. 0.2510. Perfect. So that's great. Okay, so that is the easiest way to do that. You could have also kind of manually done the computation in Excel. I don't think that that's important. But yeah, so this was our formula for that. And then let's look at the tables that we had just talked about in the binomial. So if you didn't watch the binomial video, you can watch the binomial video on how to download these. It's just go to the content tab, go to the resources portion of the content tab, and download probability tables. Okay, so now we're looking at Poisson probability. So last time we looked at binomial, now we're looking at Poisson. So the Poisson starts on, looks like page 6 of this PDF. The Poisson tables are set up a little bit differently, all right, whereas it's kind of just one long big table. See how it just kind of continues? And all we're looking for is our mu. So what is our mu? Our mu in this problem was 1.5. So we just kind of look across the top here and we just find our mu. Boom. There is our mu. Okay, 1.5 is our mu. So now we want to know what's the probability of x equaling 2. So we go down to x, find 2, come across 0.2510. Perfect. So we got it calculation-wise, we got it in Excel, we got it on a table, and that's that. Okay, and there's nothing else really. If I asked you the question, okay, well, what's the probability of at most 2 typographical errors? How would you do that? Okay, you could do this formulaically, right? You could do this with the formula, okay, and it would just be adding the probability of x equals 0, doing the formula for that, the probability of x equal 1, doing the formula for that, and the probability of x equal 2, doing the formula for that, adding those all together, right? You could do that. You could also come over to Excel and do it like this, okay? Changing this 0 to a 1 and saying, I want the cumulative, meaning I want everything up to that point, and it would give you this number, okay? Or you could go to your table, all right? And you could say, oh, well, we have all of our probabilities here at the table. So we have 0.2231, 0.3347, and lost my train, 0.2510, and you just sum those together, and we get 0.8088, right? So there's multiple ways to go about doing this. On a test, I'll probably have you do some computation, so you'll actually have to do this computation on a test. But if I ask you for some big long cumulative thing, you'll have the table in front of you. Like I'll give you the tables on the test, or I'll give you the tables like where you need them. So yeah, that's that. So that is the Poisson probability distribution. I know this was a short video, but we kind of covered it all. Please let me know if you have questions, guys. I know I harp on this and I say it every single video, but I really, really do mean that. I am always here to answer your questions. I really want to help. I know that this is a tough course. I know that this is a course that kind of goes against the grain for a lot of business majors and whatnot. I get that. So let's get through it together. Ask me questions, post questions in the discussion board. I'll try to be as prompt as possible. Like I said, I try to get back in one day during the week, within 2 days on the weekends, but usually I'm a lot quicker than that. That's just kind of the standard that I'm trying to set. But yeah, get at me and we'll figure things out. All right, thanks so much. Until next video when we'll learn normal. But this has been Poisson probability distribution. Thanks so much, guys.